All right, today we are going to be looking into power supplies. And during this, the objectives for this particular lesson are we are going to identify the characteristics of power supplies and the connectors. We're going to be able to select a power supply based on given specifications and the needs that we would have for that computer. Describe how to remove and install a power supply, and identify common problems that come up with power supplies and how to address them. The BSMs we would be utilizing for this particular one would be communication, which is critical in the troubleshooting, and growth mindset, wanting to learn new things. All right. Electricity. Three main things that we need to have a basic understanding of with regards to electricity would be volts, amps, and watts. And electricity by itself is the flow of negatively charged particles called electrons. And the voltage, I think we've gone over this a little earlier, that is the pressure of those electrons through the wire. And obviously voltage is measured in volts. And the total amount of electrons traveling through would be called the current, and that is measured in amperes or amps. The amount of electrical power called wattage, measured in watts. And the way this was kind of expressed to me was think of it like water flowing through a pipe, where I believe the voltage would be considered the water, the amperage would be the diameter of the pipe, and then the wattage would be the amount of water, total amount of water that would be passing through. Simple formula to remember is wattage equals volts times amps. And then the resistance measured in ohms. If any of you have ever used a multimeter, they typically have an ohm measurement, so you can check the resistance on the wire. Also uses a quick way to determine, you can use a voltmeter as kind of like a rudimentary fox and hound as well. Any basic questions on the terminology of volts, watts, and amps? Okay. All right. Understanding the flow of electricity, two different ways that it is actually measured would be alternating current and direct current. Alternating current oscillates between negative and positive. Negative would be the return feedback on it. AC travels on a hot line from the power station, and then the neutral line helps disperse any groundings, or creates a grounding so that it prevents an electrical short within the line. And then basically there's everywhere else in the world has 220 voltage as their primary measurement, how they would disperse electricity. And then there's the US, because we like to do things differently. Apparently we do things in 110. And then you have direct current, which travels in one direction, and it's the type used for most electronics. So when electricity comes into the house, it is on alternating current, and then for the electronics to be able to use it, it has to be in direct current, and we have to convert it from one to the other in order for the devices to actually be able to use it. Comments, questions on this?
Doesn't Japan also use only 100 volts?
Do what?
Japan itself, don't they only aren't they one of the countries that use the lowest amount of electricity?
They're a little bit different.
Yeah.
Chris, you can't come in asking about Japan, man.
Well, I'm not asking about it. I'm just saying I read it somewhere that they have one of
Knowledge
the.
on Japanese electronic standards is a little out of date, so I might have to actually look that one up. Typically outside the U.S., one of the most common one you will come across will be 220. Within the U.S., it would be 110.
Okay.
So, let's say you bought a laptop, or somebody comes to you, one of your coworkers comes to you, you bought a laptop, or they bought a laptop while they were over in Germany. It was really inexpensive. They got a great deal on it. Works great over there. They bring it back here. It doesn't work. And then they went back over there for, to go back home for a business trip, and it works just fine again. There's no problem. And then they come back here, it doesn't work again. How would you explain this to them?
It's running off of a 220 volts.
How would we get around?
Ours doesn't supply enough voltage to it. Radio Shack used to sell those. It used to be like a power inverter that would allow you to use your stuff in different countries and whatnot, and vice versa. So you'd have to get something like that in order to use it in the US.
Yeah.
Because it wouldn't get enough power. What would happen if you bought a cheap one here and you took it over there and plugged it in? What would happen?
Ooh, that might burn out.
Might fry it.
Yeah.
Yeah, if you can get it plugged up.
So if they came here and they wanted to get their laptop, if it was a laptop, we could probably get them a different adapter. So we could get them a 110 adapter, and they might be okay if it was a particular laptop. If it was a desktop, if it was a cheaper desktop and they're bringing that over here, we actually might have to go in and change out the power supply if it's a cheaper one. So that's what we would do here. If we're going over there and you plug it in and you don't have, an adapter, you'll burn out the unit. Questions, comments on that? Concerns?
Yeah, Kelly, how about they don't have any converter there in Europe or in Germany?
No, you do. But if you just basically took a plug adapter.
Oh, just plug it. Oh, okay.
Real simple, has no circuitry. You just put it on your computer and plugged it in without an actual power converter, you would burn out your unit. If you actually had the power converter, that, instead of just buying like a cheap little adapter, so that the US plug would actually fit in the European style receptacle.
Yeah.
If you actually bought the power converter, you would be okay.
Okay, got it. Thanks.
But as of right now, Kelly, I've been reading and been noticing that the overseas have been becoming more supportive of our electrical differences. And now that with most devices, you probably just need your USB input. So a lot of those things now are located throughout airports and hotels. So you're better off now. But like Alvarez said, Radio Shack, Circuit City, we used to have to sell the international adapter. To ensure that we keep our things safe. But as it stood, that was a big thing in the early 2000s. I think now we're starting to be more accommodating.
Well, there's also some things they've done within the like the actual power supplies and the power, with a lot of electronics. If you look on them, especially if it's something that's meant for travel, like like hair dryers and stuff like that, if you're going to travel with those, and a lot of electronics, if you actually look on the plug, there may actually be a switch on that plug that will say 220 or 110, and switch it back when you come, and then the device will work just fine.
I bought this product from China, and unfortunately, it only came with a strange plug-in.
That's a
But on it,
European
it says
product.
it'll take 110 or 220. So I just have to plug a special adapter into the wall so I can use this.
You got to take that to England.
Mhm. Yeah, they have the 2-pronged or the 3-pronged with the grounding. So it's the 3-pronged side by side.
Yeah.
I believe Italy's the same way.
But it
Mhm.
says right on the block 110 or 220, so it works just fine.
Yeah.
So say coworker in your office comes to you and says, hey, my computer, is not working good. Power supply doesn't seem to be working. Can you possibly help me out? Your department's running on kind of a bit of a budget. You pull the power supply out on it. Would you want to open that up and look inside, see if you can figure out, what came disconnected and figure that out? So would you ever break open the case on a power supply?
No.
Replace-
That's
replace-
scary.
If you're not
That's
expert on a power supply, you cannot open that one. It's electronic short.
Exactly. They're rather inexpensive. So, I mean, relatively speaking, it is a much better idea just to toss it, or you can mail it off and have another technician look at it if they want to do that. But it is much better to just replace the whole unit. As a IT tech, you will never break open a power supply casing and try to repair what is inside of it. You will either just change it out, or you will hook it up and it'll tell you if there's actually something wrong with the actual power supply itself. If there is, you can either mail it off and have them repair it, or just swap out the unit. All right, PSU or power supply unit. It is the main source of power inside of your PC, supplying power to all the internal components. There are cases where you may see multiple power supplies set up within a unit, especially in a server scenario, and they will actually have those power supplies hooked up to different switches on the breaker. So in case one breaker goes out and the other one is still up, that unit is still receiving power. This is something that they will also do when flashing the memory, the read-only memory on the hard drive. They will hook it up to 2 different power supplies to just kind of have a double backup just to make sure so they don't brick the unit. And the main function of the power supply, it's going to convert alternating current into direct current. And as we just discussed, 110 for US, 220 for Europe. And then we talked about the selector switch on the back that you can go ahead and select, and whether you are here or there for 110 or 220. Like if you have a unit here, it's set for 220, the unit's just not really going to work. So when you're troubleshooting, be sure to look at the back of the unit and make sure it's set correctly for 110. The volts that will come out of the unit typically come in 3 basic flavors. You have 3.3, 5, and 12. And a lot of times that depends on the age of the unit and the type of device you're trying to power within or component you're trying to power within the actual unit itself. Now, one of the things you always have to remember is it's technically 5 different, because you have 3.3 positive, you have 5 volt positive and negative, and you have 12 volt positive and negative. Depending on the component you're trying to hook up will determine which one you're using. Any questions on that so far?
Are those voltages, are they color coordinated? Like 3.3, is it a specific color?
Yeah, it should be 3.3 is green, huh? And 5 is red and 12 is yellow.
Good question, Ms.
I think it's based on
King.
the, like, we'll see, they actually will have a schematic later based on the pinouts. It will tell you.
Okay.
So I do believe it is color coded based on voltages, but it's always be sure you double check the schematics and make sure, because It doesn't, just because it's typically that way does not mean it's always that way. And there are some units that they go for more of an aesthetic look rather than a functional build. So all the cables will be the same color.
Glad you said that, Kelly, because I was about to hit you with that.
Go back to back.
Also, with this slide, I was about to say what you just said. You could get a power supply with all black, so you wouldn't have that differentiation. So this ketchup and mustard type thing is really basic for run-of-the-mill PCs, but it can get pretty cool looking with just a solid one color. So that's not where you're going to lean into. Like Kelly said, schematically speaking, you'll have something to address those powers, but also your devices is only going to use a certain type of connector, which we will also get into. I wanted to piggyback off Kelly with this slide. I know you see that little dash in front of 3.3, but it's just the dash to let you know the information. Don't get it confused with the other dashes on the other ones. 3 plus 3 is only positive. It's not a negative 3.3. Kelly said it, but I wanted to make sure that you saw that because it can kind of, the way it's sitting out there, it may get somebody, but it's only positive 3.3. That's all I wanted to say, Kelly.
Yeah, they probably could have arranged it differently and put the 12 volt first and then put 3.3 at the end so there was no confusion, but maybe for future cohorts we'll have that corrected.
But it says your 12 volt is negative, is it not as well? I'm sorry about that.
Do what?
I was saying your 5 voltage, it can be positive or negative as well, but 3 is only positive.
Yes.
Okay.
3 is only positive, and that tends to be more of a legacy type voltage for the most part. You will see some components out using 3, but that tends to be an older type. But you do still come across it. More recent components in computers will typically be 5 volt and 12 for the most part. All right. So the capacity that you're looking for when you start adding up your components measured in watts, and you want to have an idea as to how you're going to be building out your unit. And then you want to add up all the components that you're going to be putting into that computer, add up all your power needs to make sure that your power supply can cover what you have, but you want to future-proof it for a little bit. So you're going to need to add, I think it's like 30% is what, it's 25-30% is what CompTIA says. But in reality, you're likely going to want 50% more because that will give you more longevity out of your units. Questions on that?
About what you just said. So is what you just said going to be on the test, because you said what CompTIA want is about 20 or 30, but actuality is 50. So what if you have 50 on there? What if it have an option for 50?
Do not select CompTIA. I don't think they put 50 on there. I think they put less, right at, or 25% more. I don't think they go as high as 50, but that's just a matter of like in real life, you're gonna want to go probably 50% more just because it'll give you more usage out of it.
Yeah, especially if you're into gaming. You're always changing out your graphics cards when the new ones come out, and those absorb more power. So, trying to stay on that edge and be faster than everybody else, you want that power supply. They got people with kilowatt power supplies.
Yep, and dual rail.
Yeah, the power supplies, when you get into the gaming side, gets pretty expensive. So it's always a good rule of thumb to keep a more powerful power supply up to date on the computer, unless you have to come out in cost in the long run.
And the connectors on the power supply are removable, so you can upgrade, you can update your connectors to match your needs, and then but you don't have to replace the entire unit if you have the available capacity out of it.
Yeah, those type of power supplies, they would call them, they'll be considered modular. They're pieces you just put in what you need and you use, so you don't, it cuts down on the clutter. And like I said, you have the parts where you can interchange where it will work and fit your actual need without replacing the entire power supply. Those are more commonly where you'll see they won't come in the mustard red and yellow connection. They would be like those solid black. They have like the rope type grates on it. And some of y'all remembered from the video when I showed my computer, all mines were all black. So yeah.
I mean, and they come in different colors. I've seen all red. I've seen like purple. I mean, I've seen all different kinds, you know, because you can custom order them, you know, to be sheathed however you want.
So, quick question.
You know, because more and more you're seeing the like the glass side or, you know, plexiglass sides of the units because you want to show off the components they have inside.
So, if you do have like an all black set,
yes, David, we are going to talk about rails in a little bit. Sorry, go ahead, Christian.
Oh no, it's okay. But if like I think that was Brian that was saying that he has a all black wiring set, how would you know the different voltages of that? Just by using a tester, or would it be specifically labeled?
It would be based typically on the connector type because the connector types are pretty uniform based on voltages.
Right.
Okay.
Right. So I couldn't connect something that wouldn't fit with whatever peripheral I'm plugging it to. So more, it's a better chance if I plug it in and it's the right connector for that particular part that I'm plugging in, then it would be the correct voltage that would be needed for it to operate without blowing it.
Okay.
All right. So pretty much inside the power supply, which we will never actually try to do in real life. You can see, you know, they basically kind of put up a little bit of a schematic. One of the primary functions when the power comes in, the first thing it does is it gets converted from AC into DC. And then it starts breaking things out into these other voltages that are going to be required by the internal components, like the, you know, +3, positive or -5, positive or -12, and sending them out. And then when you're looking at the schematics, you can see, obviously you can't see my mouse, so I'm not going to point at it. The 20-pin connector, this would be the symbol for the 20-pin right next to it on the right side of that particular schematic. And that would be the physical representation that Marvin's pointing to on the right-hand side as your main power supply for your motherboard. Any comments, questions, concerns so far on power supplies? Okay. All right. What we got next? All right, this is what we were speaking about earlier, the dual voltage option, which is becoming far more common on laptops, desktops, most consumer electronics and stuff like that, especially considering, well, prior to 2020, you know, people would travel a lot and take their devices with them. So you would see just above your ICE cable, the red switch that can be flipped from either side, which will tell you either 220 or 110. You know, and not such a big deal in the US. If you have a 220, it just means it's not going to get enough power to actually function, though it is a lot more critical when you go over to Europe. And if you have it set on 110 and you plug it into a 220, it could possibly damage the unit, but they tend to have internal fail-safes for that. Questions, comments, concerns on that? The selector switch. Okay. All right, power switch. Now, this is kind of an important one to remember, especially if you're swapping out a power supply unit, hint for test out. When you're swapping out a power supply unit, there is an additional power switch right next to the IDE cable that you can turn on and off. It's kind of a fail-safe, like if you are struggling, like you're not able to power down your unit, you pressed and held the power button on the front of the tower, it's still not turning off, the computer seems to be held up, you have a secondary option on the back of the unit you know, or you can unplug it, though I wouldn't suggest that, because the power switch on the front, when you press that, it's sending that information through the BIOS telling it you want to power down. The switch on the back of the unit is more of a hard kill of the power supply. Now, when you're installing a power supply unit and or you are troubleshooting a power supply, always, like, if there's no way it's not turning on at all, you've checked your power outlet, you've moved it to another power outlet. One of the things you always want to just double check, because it's kind of one of those easy things to miss, is make sure that this switch is in the on position, because if it's not, doesn't matter what you do, it's not coming on. So when you actually flip out the power supply unit, right before you turn it on, flip this to the on position, then you press your button on the front, your power button on the front, and then it will signal the BIOS and everything should work as usual. Any comments, question on the power switch in the back? Oh, sorry, real quick. As we were talking about, the front button goes through the BIOS. They typically call this soft power. This is one you definitely want to remember, soft power, for the button on the front of the tower, because it's basically asking permission from the computer to turn it off. So you want to remember that, where on the back, it is more of a hard on or off.
You froze for a second, Kelly. Did everybody catch that last thing he said?
Yes.
Okay. You're good, Kelly.
One of these days, my internet will get back to working normally.
Hey Kelly, I have a question.
Go for it, Jose.
It's not about this lesson. It's about an earlier one when you mentioned the BIOS.
Okay. Can we? Well, hold on, Jose. Can we possibly hold that question, like write it down or put it in the chat, and we can try to keep on T-session right now. If you put it in the chat, Marvin will probably be able to help you. Or if when he takes over, I can jump in and look at it and message you on it.
Okay, I'll hold it till lunch. Is that fine?
That works too, if you want to do that.
Okay, thank you.
No problem. I just want to try to stay on course with it real quick. All right, I guess, and with that, I will be handing over to Marvin right now for cables and connectors. And Jose, if you want to drop that question in the chat, I might be able to assist you right away.
David asked about rails, and the way that we
will be.
We have a couple of more slides that'll talk about that, Kelly, before I mention it.
Yeah, they do. Like it's probably in about 6 or 7 slides. They talk about the dual rail.
Okay. Well, hold it to then, David. Cables and connectors. As you can see, that big one, it's the 20 pin or 24 pin, also called P1. Ding, 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 test question. Could be that. The 4 that's attached on the end of the line of those pins are typically there for what we would consider those gaming systems will enjoy that extra power. Most of the aftermarket ones that you'll buy will at least have 24. But if you just have a 20 pin connector on that motherboard, that will be just fine. So you'll just not use those 4. That's all that will happen. Now, can anyone just call out some power supply numbers that they are used to seeing? Maybe a person that games, maybe just a person that's been in the market to have to replace one. What numbers are you used to seeing? How are they? Give me some numbers right quick.
I mean, it's like far as wattages we're looking for when we go buy them.
Yeah.
Like right now, I'm currently on mine. I'm running a 750 watt.
750 watt. Anybody seen something higher than that or lower?
Yeah. I've done both 1250 and 1000.
Okay. Now, I wanted to make sure that we understood the significance of those numbers. That's going to be, you have to realize and make sure that your number is either peak power or continuous power. And a lot of times that number, unless it's rated, they have certain rating systems. just like with cars, you know, you buy some speakers, you get an amp, it'll say 800 watt amp, but the RMS or that continual power is really just 500 or 600. So your power supply has sometimes will fall into that situation. You're getting a big number, but you're really hanging out at a number below it. So that's something also to keep in mind. Just to throw that out there. I wanted to talk about, piggyback on what Kelly was saying. With the pins, you got the positive 3.3 volt, plus or minus 5, plus or minus 12. And all of those will feed the components on the motherboard. And you also have certain pin connectors that could come, like I just said, that 4 pin right there for extra power, namely to probably power that GPU, the graphics card. That's a 4 pin there. Okay, here goes some other really used most commonly. You have the Molex, which is also called it's a 4 pin connector. And as you can see, like Christian, you were asking, that Molex will supply 5 volts or 12 volts, depending on where it needs to go. And you'll recognize that with what you're using. So you won't have to think about it on the back end. That 4 pin is going to take care of that for that device. And then we also have a mini 4 pin connector, and that goes to your fans and to your floppy disk drive. Who has seen one of those in a while? That's not in there. I won't say that.
I probably haven't seen a floppy drive since probably 2005, 2007, somewhere along there.
Joseph, you're so spot on, because I finished college and I still had a floppy in or around. So that's super accurate with that time frame. But that's not something we use. What do we trade in the floppies for, class? What do we use?
Flash drive.
Yep, flash drives. Chris, you about to say something? I see you off mute.
Sometimes that Molex 4 pin connector, they'll only have 2 wires connected to it. I don't know why. They sometimes just decide to make it only a 2 wire, but it'll still have that 4 pin connector on it. So just be aware of that. If you're going through and rearranging things, that you want to make sure that if you pulled one that off that had 4 pins, it needs to go another 4 pin one back on it.
Now, I thought I had show and tell available for you, because I think I have one out here somewhere. Maybe not. Maybe after lunch I'll show and tell that. But thank you, Chris, for that information.
What, a floppy disk drive?
No, he's talking about the Molex.
Molex. Sometimes they'll take off one of the blacks and the yellow ones, so that all you've got connected to it is a red and a black.
Yeah. Let me see something.
While Brian is taking off, I got some more. We got the SATA. We already know L-shaped, and it has the ability to supply 3.3, 5, and 12. And we know that it's hot swappable. We're talking a language that we know. And now we're down to PCI Express, which is that graphics card possible slot, and it will require extra punch. And that's why you have the ability to add more to that power connector. As you can see, you have a 6 pin, but if you had a graphics card that had 8 pins and you had the available 2 more there on the actual connector, you can just plug it all up. And if you don't have that, you can leave it unplugged and it will work just fine. That's what they're trying to let you know. It's a lot of the aftermarket power supplies will come with extra connectors and to be utilized in that situation if necessary. But it's not guaranteed that you'll have to use it, but that doesn't stop us from using it. What other situation did we come across last week with this type of scenario? What did we talk about last week? I want to know if anybody remembers. conversation about the fan speed.
The fan pin header that had only 3 pins instead of 4 pins.
Instead of 4 pins. Appreciate it, Chris. That's exactly right. Doesn't stop you from being able to utilize it. It's just another option. If you have it available, can be used. And this is a pinout. And as you can see, I think this talks more about what Christian was asking and also what Chris pointed out and why those particular connectors can feed those devices with the same connector. If I buy a hard drive and it has a Molex or a SATA power connector, if you look at this pinout here, I'm hovering over the Molex 4-pin right here. 12 volt is my yellow and black is my ground. Black is typically my ground. But like Chris said, what if you are lacking a ground or a black and a yellow and you just got a red and a black? That device is going to be able to be used with a 5-volt device that needs plus 5 volts. And it has it there with the ground. If I slide over to this serial over here, I have +3, +5, +12. As I plug this SATA in, it's going to power that device depending on what that device requires. Although I have the opportunity to service the whole gamut of power there, I'm going to utilize what I need. The power supply and the device is smart enough to communicate that. That's what we're trying. That's the gist of what this picture is and what we're trying to get to.
Also, for this picture, just to kind of keep in mind, it is unlikely you will come across a question on the A+ with regards to a pinout, and a schematic like this.
Correct.
However, in the real world, when you're working, it's a real good idea to be able to read a schematic. So yes, I would, try to at least get comfortable with looking at them and understanding them. But for the purposes of the A+, it is unlikely you will run across a question regarding it.
So this is a Molex connector. This one I have is a 3-pin actually. This has come from a modular power supply. So this would be the connector that I would plug into the power supply itself, and it supplies the power to the Molex connectors. And just a quick rewind from last time when we talked about the IDE cables or the PATA cables. This is a ribbon cable, and they would normally be labeled, as you can see when we talked about like master and slave. That's how the cables would identify what is the primary drive or what is the secondary drive. And then they would have labeled where the other end would go into the CPU board itself.
Appreciate that, Brian. I got show and tell as well. I don't know if you can see this. You can't, because I can't see it. Let me turn off my my background here. Choose virtual background, yes, and none. So, just like Brian just showed us a Molex. So I have this, which will service as my Molex input. You see the colors, black, red, black, red, yellow here. So I'm plugging this actually into this device because I'm changing it to SATA. So it's able to identify that I can pull that 12 or that 5 through an adapter that I can use as a Molex if I need to, or I'm going to use it as SATA. That's what I was going to try to show you. So the power supply is very smart. It can identify those things through communication with the connector through the device. So, and like Kelly said, to kind of piggyback on that, very good information to be able to understand, not something that you'll see on the test, on the certification. Form factor, Kimberly, if you don't mind, ma'am.
The form factor determines the size of the power supply and the placement of screw holes and slots used to anchor the power supply to the case. ATX standard 150 mm times 140 mm times 86 mm desktop power supply unit provides P1 connector along with Molex, SATA, and other required cables to the motherboard. Mini ATX and micro ATX small power supplies designed for mini ATX and micro ATX cases.
Thank you, ma'am. Just a heads up from what we're saying, that as you get smaller, the placement of that power supply and the size of that power supply may vary. But as a standard, the ATX will come with the P1, Molex, and SATA, and all the rest. It's your biggest one. So it's going to have all of the connectors that you would typically need. And of course, as you pay more for a more powerful one, you'll gain some more connectors for the need for that bigger power supply. All right, David, are you available to read? Since this was your question, we can kind of knock it out.
Rails. Generally, power supplies, DC current is split into three primary DC voltage rails, 12 volt, 5 volt, and 3.3 volt. Each rail has a maximum amount of power it can supply. Powerful computers with advanced CPU and video cards require more power than some rails can provide. Multiple 12-volt rails with overpower protection allow to balance the circuitry and supply the required power. Today's power supply manufacturers provide single and multi-rail PSUs.
So I think to hit on what your question, I think that you may have is that you have the benefit of newer power supplies being able to increase the power as needed. And it's done because that device is able to receive and need more power. So you have the ability to, how can I put it, Kelly? You're combining more than one to actually increase that power in that particular rail as necessary. And it's something that's done not by your doing, it's done by the communication between the power supply and that device.
But also, I mean, they're kind of splitting it up because you can only run so much over a particular rail the way they have the architecture set up. So depending on the needs of the computer you're in, you may need to set up other rail, like you may need to have a power supply that has multiple rails in it in order to provide enough power to be able to service all the components you have within the unit. So a single rail would probably be a more basic machine, like a thin box or whatever. And then, a gaming PC might have a multi-rail system set up because it needs to power the GPU, which even the GPU by itself has its own, processing unit, and requires its own independent power connection. So depending on your needs will determine which system you will use. Does that make a little more sense to you, David, or you need a little more?
And also, David, for you communicate, those more expensive or more powerful power supplies will include more rails. That's another thing. You typically with ATX and the standard ones that come along with probably built to order PCs that you can buy from stores don't have a significant amount of extra connectors in it. But of course, with the newer ones, you have the ability to add more as necessary. That's one of the takeaways from having a better power supply. And I think that's also leading towards the question that you had as well. But please, if you have something else.
Well, the part I don't get is is each type of voltage a rail? Like, is there a 12-volt rail, a 5-volt rail, and a 3.3 rail, or is there like one rail that supplies all of those for like the ATX connection to the motherboard, and then another rail that supplies those voltages to peripherals? Like, I'm not sure I understand which one it is.
So as we go back to this pinout, if you notice, those connectors, like the 8-pin express right here and the 6-pin express, those are only 12-volt rails. You're not going to have the ability to address how much you can send through those particular connectors on that power supply. So those are 12-volt, as well as this 4-pin up here power connector. It's a 12-volt, but you do have the ability to identify certain ones being able to have multiple rails going to it, like the Molex and the Berg 4-pin, which I'm trying to think about where that connects to. So your rail system, when you hear rails, they're identifying the connectors and the amount of power that could possibly go through those connectors. But to retain some information, the 12-volt rails will be the PCI Express, 8-pin or 6, and you will know that you can, with the SATA and the Molex, it varies depending on the device that it's trying to power. Kelly, you have
okay. So, well, I mean, basically what it is when you have a 12-volt rail, that's one rail. And then, you know, what it is the combined voltage to equal 12. So each rail would be 12 volts. So if you have one at, 12, and then you have two at 5, the 2 at 5 would be the other rail. And then, or a 5 and 2 3s, that would be another rail. So each rail it has a capacity of 12 volts. Does that make sense? Whatever combination you have making that up, it's a capacity of 12 volts.
Okay, now I think I get it.
You could have like 2 3s and a 5. You could have 2 5s. You could have a 12. Make sense?
Mm-hmm.
Okay.
Wattage capacity. I think we hit on this. If I could get Kareem to read for me.
Power supply has a wattage rating for a total output maximum load. For example, a 500 watt, 850 watt, or 1000 watt, and individual watt ratings for each of the voltage output circuits. These voltage capacities are listed in the documentation and on the side of the power supply. Video cards draw the most power in a system from the 12-watt output.
Thank you, Kareem. And we kind of hit on that with that pinout. You notice that the PCIe has 12 volts on those pinouts. Those are the ones that will be going to the video card, 6 and 8 pin. And like I mentioned earlier, you got power supplies, and like Joseph said, you can go well past 1,000 watts, and they have a rating system. So you have a gold standard and a gold rating, and those are power supplies that consistently hit that number at a more rate that makes you feel like it's peak power, or it can be actual power. So that's something that you need to consider. All right, determining wattage capacity. Faison, all yours. You don't have to read the green.
Consider all components inside case, including USB and firmware devices. Add all the total wattages of all components, then add 30%. Purchase a quality PSU with a warranty rated with total wattage calculated.
Thank you. And if you're building one, this is kind of a chart that you can use to identify how much you think you need your power supply to have. And you'll add that 30% to it as well. So if you got a standard ATX power supply that you're looking to purchase, that motherboard and its components is at least 300. Let's say if you're gonna game on it, so you got to think about having at least 150 to 300 with each, and then you got to, if you add another card, that's another 100. So we're already at 700, and we haven't even talked about hard drives or FireWire networking cards. So it's easy based off this chart to get past that standard, what, 550, 500, 650 maybe, up into that 700, 800, over 1,000, depending on what you want to do. When you add your 30%, 30% for tests, we say double or have at least half of that. So you want 50% in real world situations, especially if this is something that you're doing and you want to have some wiggle room as you continue to grow and set up your system. All right. We talked about some of these, and the ones that we talked about, I'm expecting you to know. So let's see. Christian, number 6. What is that connector?
Should be your SATA connector, correct?
I like it. Pass the ball to somebody else, Christian. Call out one of your.
Pass the ball to Camille.
Miss Camille. Let's work backwards. What's number 5?
The 20 pin power connector.
Also known as
P1.
I like it. Pass the ball, Camille.
Kareem.
Back to you, Kareem. Number 4.
That's a floppy. Floppy. Is that the floppy?
Yeah, and that's how many pins if you can count it out.
Man, I can barely see it.
Me too, but I
6 or 4.
4. I like 4. And we know 4 is floppy anyway. All right, Kareem, pass it along.
Let's do Joseph.
Number 3, sir. Still on mute if you're talking.
Oh, number 3. There you go. Yeah, sorry. Is that like the PCIe power?
I'm leaning in towards that. Kelly, you got to confirm that for me.
It looks like a P8 or a P9.
Yeah, I didn't hear what he said.
He said PCIe power connector, but
I think that's right.
Okay. We'll know in a second, Joseph. We'll confirm it.
All right.
Pass
in a holding pattern. We're gonna say, let's go with David.
All right, David. Number 2.
That looks like, well, it's a 4-pin connector. Could be for a CPU, or it could be a PCIe connector too.
I like it. Go ahead one more time for me, David. Pass the ball.
Let's do Phazon.
Take us home, Phazon.
I'm gonna be honest, I can't really recognize it.
Somebody else will. Pass the ball.
Let's go with Marcus.
Marcus. Help out Phazon if you can, sir.
I don't know, because I was getting number 3 and 1 confused.
Okay, what did you think 3 was? If you were, don't tell me what you were, the names that you were thinking about.
I was looking at a SATA, a Molex thing that isn't right.
You called out
just because
number 1.
Huh?
You did call out the answer to number 1. That is your Molex connector.
Oh, okay, but that's what I guess I was having trouble getting it confused with number 3.
Okay, well, for just clarity, the Molex will be a 4-pin, and if you notice, most of these aren't round.
The angle of 3 made it hard to see.
Yeah.
Yeah, I guess it is just the angle. I can't really see any, but that makes sense.
Yeah, that Molex is round and it's going to be a 4-pin. And yeah, we didn't do you a good job of making it easier to see some of these connectors. So that was pretty good. Ooh, come on, guys. It's after 2. I mean, it's 2 after. It's lunchtime.
Ice cream
Let
truck.
me make this Molex connector easy for everyone to understand. There's always going to be a red and a yellow cable on the outside. The red cable is always 5 volt. The yellow cable is always 12 volt. And the 2 in between are always black, and they're both ground.
If it's colored, Joseph, you're right. If it's colored, that may be the color scheme. If they present that color scheme, you're totally right. If it's all black, then there may be some, there's variances there. But,
honestly, if you're a technician at a company and you have cables that are all black, you really need to change that. That's very unsafe.
I can see that too.
Especially from some new technician. Especially if you hook that into a fan, you're going to burn up that fan.
I can see some bad issues with that. I can see some things that we would want to happen. And I don't know if that's something that's out more commercially as opposed to just for that person that's building at home and wanting to aesthetically create an experience. But you're right.
No,
if
I don't.
Those colors, then that
Yeah,
is the correct way. But
I don't think you're going to find companies out there, like corporations out there, that are going to sell anything outside the industry standard schema, right? So it won't be all blue, all red, all green, all black.
Yeah, from my
I
experience,
mean, I can
from what
make
I
them
saw,
that way.
you won't have them with that just solid one color. That's more primary on a consumer side level, primarily for people who are like custom building or doing gaming stuff. But within the business, it'll you'd see how it's supposed to look.
Totally in agreement with that. I think everybody got their ones right from what we're looking at, and it's time for lunch. So we'll see you back here in 1 hour, your time. So to know. And the question left me not 100% locked into giving all the information to make you feel comfortable and me feel comfortable. So I did some digging. So you have 2 types of power supplies. You have a power supply that's single rail, or multi-rail. As you can see in this picture, the single rail has one mode of architecture built into that power supply to deliver voltage. With the multi-rail, as you can see, there are several rails identified in a way to bring forth those 12 volts. You got, as opposed to just one here. Which one's better, you say? I say, and the literature says, there's not one consistently better than the other as it stands. And everybody's going, your mileage may vary. The key point here is that when we talked about the OCP, which is the overcurrent protection, if too much voltage come in too hot on this single rail, you only have one OCP trigger that can stop it. And it should stop it before anything start burning up. Whereas on each rail, you have the ability to stop it here. So it depends on how the architecture of the rail is set up. With the single, you got one connection. With the multi, you got several connections. And like I said, the greatest takeaway from that slide or this information is that the OCP on the multi, you have several points of shutting it off as opposed to just having that one point over on the other side. They both typically run as cool. There's not a difference in that. And then, you know, some people, some manufacturers may claim that it is, but there's nothing significant across the board. So that's it in a nutshell.
Thanks for that. Makes it a little bit clearer.
I appreciate it. I said, hey man, I'm gonna eat this lunch, but I'm gonna check this out. So I got a funny video too that I'm posting in Slack, as well as that information that you just received. Well, I'll end up posting it in the chat, not Slack. Joseph, you're right. Each one has its own OCP. Yes, and that can be significant, but still the goal is to stop it before we get to an issue. And ideally, both will work that out before it happens. Oh, I have to. I'm always on the other side of this. So Kelly, I'm clicking view pairs, and then I'm going to stop sharing, or no, I can share. No, this is not it.
No, well, you just gave away all the answers.
That's the answers.
Stop share.
Oh, okay, stop share. That's it. Okay. Hey man,
Yeah, there you
go. It's still weird over here. Kate, are you able to see now the images of? Okay, gotcha. Okay. All right. Take some time and fill that out. Hey man, it's a little work in progress.
We'll get there.
I always watch from the student perspective, so.
I'm sorry, we're supposed to match, right? I just noticed it.
Yeah.
Okay, sorry, just came in. Thank you.
No problem, Keith. Yeah, just match it up for me.
Hey, Kelly, do you mind providing the link again? I actually closed out.
Let me see if I can find it here.
Appreciate it.
Yeah, give me 1 second.
I got you. If I got it set up. I got it there, Kelly. It's already there.
All right, thank you.
No problem. And that second link is a YouTube video from a guy named Linus, which I'm pretty sure if you are slightly techie, you know him in that industry. He has a lot of fun videos. He had a little quick 5-minute videos about it. And he went on to say pretty much it's not a big deal, but this is what you need to know about it. So I think I did that as well.
How do we supposed to match it? Because mine's not moving.
You tap one, then tap the other.
Yeah, you click on them.
Are you viewing it on the Nearpod actual web, your own Nearpod, not the screen share?
Yes, sir. It's doing it now that they mentioned it. I got it. Thank you.
Just a little latency.
Most have kind of wrapped up on it.
I've done some electrical work in the past, and so I kind of think that there is maybe one supply difference between the multi-rail and a single rail.
Speak on it, Chris.
Like the reason why they put a house on a bunch of fuses on a bunch of circuits instead of just one is because it's kind of a safety thing. It also helps to make it so that things can get, basically you can blow a circuit and not blow up a bunch of things or do damage to other things. So I don't know if that has anything to do with possibly why as well. It's not going to have as much wattage going through any one of those rails by it being multi-railed.
Yeah,
So if a single component spikes, it doesn't Yeah, the whole system.
That was my major takeaway even by looking at it, that as you see, you have, if that one rail is damaged, I feel like with that amount of power flowing, there's more opportunities for a more significant issue or damage versus breaking it up and allowing that to flow in those individual rails. So that is a great takeaway from it, Chris. And I think that's the biggest, is more safety than anything. But the OCP, if it does its job, it should do its job across the board, in a nutshell. But you're all right. You're right. The more breaks that you have in there, the better opportunity for a significant issue to occur. You can kind of minimize the impact on that issue. Oh, I'm off camera. Got to see my face. I'm gonna push on past our little exercise now. Let me bring it back up. Steps to remove and install a power supply. Miss King, if you don't mind reading for me, ma'am.
To remove a power supply, first turn off the power supply switch and unplug the AC cable. Second, unplug the power supply lines to the motherboard, drives, and cards. Third, remove the power supply from the case. Look for screws that attach to the power supply to the computer case. Be careful not to remove any screws that hold the power supply housing together. And to install a new power supply, follow the same steps in reverse order.
Thank you, ma'am. If these steps kind of mimic steps of most things dealing with the computer, you're going to power it down and make sure that it's unplugged. And if you see the picture here, those 4 screws on the back of the case typically are the screws that's attaching the power supply to the case. Those should be your main points of connection there. So once you remove those 4, you should be able to wiggle that guy out and then replace it or upgrade it, however the case you want, and follow those steps in reverse, like Kadon said. And ideally, you won't open the power supply by just removing those 4 screws on the back there. Are we climbing? Okay, it's time to climb. So another quick little exercise about today's power supply T session. As you start to file in, I'm gonna ask some questions about what we just went over. So we got 18 people logged in, but 14 on the screen. Oh, okay, 15. Okay. I think that might be it, Kelly, actually. Maybe some people still lagging from coming in. So I'm gonna go ahead and continue. Try to save your ears. Which of the following is a consideration when purchasing a power supply with the correct voltage? Which of the following? mean, y'all already see it. I guess hiding the names don't help. I don't know. Maybe you want to see it. I'll let you see it. What feature of ATX systems prevent a user from turning off a PC before the operating system has been shut down? See you, Camille. What type of power connector did a floppy disk drive typically use? Almost wrapping up. A user attempts to turn on a computer and receives no response. The user calls the tech to report the computer is not booting and a faint smell of something burning. Which of the following tools will best help to identify the issue? Which of the following tools? Camille's trying to pull away on us. Last question here. If a power supply appears to be failing, the best way to test the unit is to remove it from the computer and open the power supply casing so you can test the capacitors with a multimeter. I'm hoping this is a true or false question on your end. Yeah, I'm so glad none of the stuff moved on that one. It stayed the same. Good job. Hey, Chris, how you manage that? I could have sworn. Oh, good job, everyone.
Go Camille.
Let me see here. I'm going to pick on someone that I haven't picked on all day, I don't think. Lukeman, have I messed with you today? Have I talked to you today? If not, I want you to read that first question and answer it if possible.
What do you think are the symptoms of a power supply issue?
So what do you think will be causing the power supply to have issues?
If it's not, I don't know, if it's not connected or if the wire's wrong or something.
Somebody jump in and assist Mr. Lukeman. What would be some symptoms of a power supply issue? What would be happening?
System randomly shuts off.
I like it, Chris. Somebody add to that.
Providing no power at all.
Yep.
Yeah, I was about to say that there's nothing to turn it on with. They're just not turning on in general.
That's a big one. Keith, go ahead and read number 2 for me, sir.
What would you do to confirm it is a power supply issue?
What would you do, sir?
What would you do to? I would test the power supply itself with something to measure with. I can't think of it right now. Am I on the right track?
There's ways you can there is a power supply tester, so yeah, that's an option. Anybody else can help them?
Okay.
I use the power supply tester, or you can take a known good power supply and put it in the computer, or vice versa, and see if you would replicate the same issue in another tower per se.
Like Joseph
Something
always
simple
saying,
you can do before you yank the power supply out. There's a couple simple things you can do.
To make sure it's plugged in.
That's one. What's another one?
Oh,
make sure it's on the right voltage. Yep.
There's another one.
Make sure that you turn on the power supply, the button that you have behind of that.
There's another one. There's two more things you can do as like a test to see if it actually works. What if the outlet's bad? How do you know that?
Would it be
Use another
fried?
outlet voltage meter as well.
I just plug it into a different outlet that you know
There you
works.
go. Plug it into a different outlet. Try a different IEC cable, the power cable for the back of the unit. Try another one of those because the cable could be bad. So before you go, these are real quick things you can check before you go opening the computer up completely and pulling out the power supply and swapping out a new one or something like that, or yanking the power supply out, put it on a tester or something like that. These are just real quick things. It'll take you a couple minutes, if that, to check, just to make sure your problem isn't somewhere else.
And also to piggyback off that, in an industry style setting, you will have a lot of multiple or similar computers. So addressing it the way that Brian said is also an easy thing to do in those scenarios by using a known good one and testing out with another once we realized that that was the option that we had. Go ahead, Ms. King.
Is it too much of a hassle to fix the problem on the power supply? Reason why it was stated earlier that like if it was the issue with the power supply, just change it out completely or send it to someone else?
It's more of a danger issue because if you actually open up that power supply unit and start poking around in there, you could actually electrocute yourself fatally. Power supplies are extremely dangerous when you start getting inside the metal casing, which is why we say don't do it unless you're like a qualified electrician.
Okay.
I'd like to add something that Kelly brought up that people are missing, and that is in an enterprise setting, like Marvin just said, you're going to have a lot of extra power supplies. That's correct. But the way to test the power supply, to make sure it's the power supply, is to test the cables that are connected to the power supply before you get into the case.
That's one way to check, yeah. Also, I mean, power supplies tend to fail in two ways, which is pretty general. But thank you, Joseph. But there's two general ways a power supply will fail. Completely all at once, or it will start having intermittent problems. The intermittent power supply problems as a IT tech is probably one of the most difficult things to try to diagnose because of the simple fact that it is intermittent. So it's can be extremely frustrating from a diagnostic point of view.
That is true. I hated that.
When it goes all at once, it's easy.
Yeah.
But yeah, intermittently, very tough to diagnose right off the bat.
Because intermittent problems, even with the shutting off, can also replicate similar to what a CPU would be overheating. So it gets hard to pinpoint exactly what it is. You may be thinking, oh, well, it's shutting off. Their CPU is overheating. So you'd probably go check it, clean it out, maybe make sure it's no dust and redo the heat sink and the thermal paste or whatever. And then it's still doing it. It may not happen right then and there, but like a few days down the line, you may get another
Maybe
call
a day
back
later.
again. The person say, hey, it's still doing it, and you're back to square one again.
Number 3, Kaylin did a really good job of explaining how we go about removing it. So I don't have to hit on that again. Go to the next slide here. All right, now we're at troubleshooting, which we were just talking about. Christian.
Power supplies fail in two ways: sudden death and slowly over time. With sudden death, the computer won't start and the fan and the power supply will not turn. Verify that electricity is getting to the PSU before doing anything. PSU will not start unless connected to a motherboard. If you want to test the PSU without a motherboard, use a power supply tester. Power supplies die slowly when one of the internal electronics began to fail. The failures are always intermittent and tend to cause some of the most difficult to diagnose problems in PC repair.
Thank you. Sound like something Kelly just was saying.
Yeah.
Almost word for word. So today with this technical session, we're hoping that we're able to identify the power supplies and those connectors. Selecting the power supply based on those specs, how to remove and install, and identifying common problems and how to address them. We hope that we did a good job of expressing that in this particular session. Do we have any questions about power supplies right now? Okay. I think we did a really good job just being able to identify those connectors is big. P1, which is your main one, that's an important one. And most of them, they kind of have certain physical attributes to them to identify them. And the 30% rule, or the 30% is what we expecting you to identify, as well as a question that could be asked. Also, I'm trying to think of something else. I think that's pretty much it. If no one have any questions, we will stop recording now, Kelly.